Need to know what we need to look at now is instantaneous rate of change. Again, it's a pretty straightforward lesson that I have for you today. We should finish it probably within about 15 to 20 minutes, and you got plenty of time. So the next few lessons, we are going to have series of 4 or 5 lessons, all on derivative. All right. Now, by the end of the lesson, you should be able to define the instantaneous rate of change of a function as the derivative at a given point. So if you're given an instantaneous rate of change, you should be able to solve for the function that satisfies the given gradient, and finally, applied knowledge of derivatives to solve simple problems involving polynomial functions, including tangent and coordinates of point. It's putting a few things together, the derivatives, the gradient, as well as equation of a line. All right. So, like I say, you must know how to do differentiation by first principle. It will be in the exam. It will be in the. I don't know whether it will be in the test. It's either in the test or in the exam, and then, or could be both actually. And then you must know how to differentiate by power rule. So differentiating by power rule is a bit more straightforward compared to first principle, but you need to know both. Now, instantaneous rate of change. The gradient function fx at a point x equals to a can be considered the rate of change at that particular instant. So this is therefore called the instantaneous rate of change. The gradient of the tangent to the curve at that point. All right. So you remember when we actually tried to find the tangent, we started off with the average rate of change. We slowly move the point up until it gets closer and closer and closer until we limit it to 0. And that is what we could write. dy dx at x equals to a, or equals to f dash a, which is first derivative, is limit of h approaching 0, function of a plus h minus fa over h. All right? You could use this or use the power rule to differentiate. All right. Now, the instantaneous rate of change for a function fx equals x squared at the point x equals to 2 is 4. You know that the function is x squared, the derivative is 2x, and therefore f dash 2x is equal to 2 times 2, which is 4. Just substituting in to find the gradient. All right, let's go on to do some examples. All right, let's look at this. Start off with the very first one. Let's first find the derivatives of fx, all right, which is f dash x, which is 12x to the power of 3. So therefore, when x equals to 2, is 12 times 2 to the power of 3, which is 96. All right, can you try the other two, please? Try the other two, please. Now make sure that you use the correct notation. This is differentiate. The first derivative is actually dy dt, actually not dy dx, because y is now in terms of t. All right, going to reveal my answer. Make sure that, like I say, you know how to write the notation. So dy dt is 12t to the power of 9. dy dt at t equals to minus 1 is 12 to the power of minus 1 to the power of 9. All right, which is, if minus 1 to the power of 9 will be minus 1, therefore it's minus 12. Using the power rule, the first derivative is 3x to the power of half. Therefore, at x equals to 4, the instantaneous rate of change is 6. Pretty straightforward. If anything comes out in the exam for this, it will be like the first need of Calc 3, I would say. Now, next, determine the equation of the tangent to the curve fx equals to x squared at x equals to 2. So you want to find that equation. How would you do this? You need to find the m, and you need to find the y coordinate as well. So if you know x equals to 2, f2 is equals to 4, correct? So the coordinate is 2 and 4. You know that the first derivative is 2x, so therefore 2 equals to 4 as well. So m, oops, what am I doing? M therefore equals to 4. So you could use y minus y1 equals to m x minus x1, which means y minus 4 equals to 4 times x minus 2. Y minus 4 equals to 4x minus 8. Y therefore equals 4x minus 4. Alright? That's how you do it. Alright. Now, you got to remember sometimes the question may ask you, what about the equation of the line tangent to, perpendicular to that point? If it is perpendicular to that point, what is m? Thank you, negative 1 over 4. Alright? So remember, it could happen. And then you follow through with all this. Once you know the m, you can just use that. Alright? Next one. Determine the equation of the tangent to the curve fx equals to 2x to the power of 3x at x equals to 1. So try that, please. First find the coordinate, then find the gradient. Or you can find the gradient first. It really doesn't matter. Either way, that's fine. Did you get the same answer as I do? Y equals to 6x minus 4? Yeah, that's right. Thank you. And I think this is the last, oh no, 2 more. Next example. Determine the coordinates of the point, or points, on the function fx equals to 2x to the power of 3 minus x that have a gradient of 5. So you need to know, you need to determine the coordinates, alright? So what you need to do is to think about how you could find all the points with a gradient of 5. So start off with finding the derivative, which is 6x squared minus 1. Correct? So therefore, we know the instantaneous rate of change is 5. 6x squared equals to, 6x squared. Yes. 6x squared minus 1 equals to 5. X therefore equals plus or minus 1. So there are 2 points in there. And then you can work out f1 equals to 2. Minus 1. 1. the coordinate is therefore x is 1, y is 1, and f of minus 1, 2, minus 1, cube minus 1, which is minus 2 minus 1, which is minus 3. So minus 1, minus 3. So you must make sure that you know x, if x squared equals to 1, x equals to plus or minus 1. Alright? Normally this sort of question will be tied to other questions. Alright, part of the questions. Can you try this one, please? So you need to determine the coordinates of the intersections between 3x cubed and 12x. And then determine the instantaneous gradient of the curve at the point. Now looking at the first question, part A. How many intersections do you think there are? 3, very good. You should be able to work out why it is 3, alright? Unless you did the same mistake as the first exam, where some of you cross out the x. You're not supposed to, alright? Just factorize everything, therefore x equals to 0, x equals to plus or minus 2. And then you should state the coordinates, and then work out the instantaneous rate of change. Alright? So it's pretty straightforward, something like this. And I've finished the lesson for the day. You should have plenty of time to do your work. Alright? Okay, of course, sure.